In the last video, I left you with this mind puzzle. Did you do it? Well, I hope you did. Because if you did, you're here to check your answers. If you didn't, you're here to be a big cheater. And you're just wanting to know the answer of it, which is sometimes okay, right? Maybe you looked at this and you were like, there's no way I'm even going to attempt this. Is he crazy? Okay, so we need to talk about the process of how we can take the molecule to the left and make the molecule to the right. A couple of things I want you to jot down in the very beginning, though. Over here to the side, number one, it looks like we have to elongate a chain, doesn't it? I mean, that's pretty evident. I'm starting with 2 carbons, and over here on the right-hand side, I've got a total of 5. All right, so elongation is going to have to be one of the ones that we're going to have to do. We know that. What else is different? Well, it looks like I have a triple bond, and then on the product side, I just have all single bonds all the way across. Perfectly okay. So we're going to have to destroy all of the triple bonds, take them to a double, then take them to a single. At least. And what else is different? Well, if I look at the product, I see this bromo group. So number 3, how do we add just one bromine onto a molecule? Guys, this is the thought process that I go through every single time that I do one of these multi-step synthesis problems. It kind of gives me a roadmap. It gives me a plan. That way I don't lose track of that plan throughout the picking and choosing of the reactions. Now, let's figure out how we can do this. The first thing said chain elongation. Right? Well, most of the time, chain elongation happens first. And the reason is because I don't really destroy this triple bond. The integrity of that triple bond stays in the molecule throughout the chain elongation step. The other thing I need to think about when I elongate a chain is figure out where the site of activity is going to be. Meaning, look at this bromine. This bromine is on this carbon. So it's probably going to be a good idea to make sure that that carbon is part of the triple bond. Because everything that we've talked about up to this point, it involved the carbons of the double bond. It involved the carbons of the triple bond, right? So if this bromine is at that carbon, that better mean that that carbon should have had a triple bond on it at some point in time. Which means that triple bond either needs to be left or right-handed. Well, if I put it right-handed, if I put it here, and if there's a triple bond at that location right there in the beginning of this whole process, then look, here's my CH triple bond C, and this is probably the carbon that will end up getting the bromine on it. So that's pretty good, meaning that this is at the end. It's a terminal alkyne. And I could end up or start with a terminal alkyne there. All right, so how do I elongate a chain? Do you remember? I add NH2. All right, well, if I add NH2, I get this CH in this case, triple bond carbon with a negative charge. I've created an ion. Now, that's step 1. Step number 2, I can take that piece and I need to elongate the chain. Well, if you look at the way this is going to be, though, it looks like we've elongated on the left-hand side, not the right-hand side, right? If we want it to perfectly match, we don't have to do this, but some people like it to perfectly match. That's okay. So what I'll end up doing is I'll erase this on that side, and I'll erase the hydrogen to the left. That way we can elongate the left-hand side. That's not a big deal, folks. That's perfectly okay to do. If that helps you see this a little bit better, then I'll do it. If the other way was going to be okay with you, go for it. Look, I just did the same thing. That shows you what type of crazy person I am today. Look, I'm going to do it again. All right, so let me put the negative on the left. There we go. So how many carbons do I need to add? All right, well, if these are the two that are involved in the alkyne, I need to add 1, 2, 3 more. All right, so back to the screen, I'm going to add a CH3, a CH2, a CH2 with a BR on it. that is how we elongate the chain. I need some kind of alkyl group with a bromine, more than likely. Very good leaving group. So when I do this, this piece, the CH2, gets attached to that negative carbon. All right, so we had the CH, triple bond C, and then that carbon is going to hook up with the carbon that was involved in that bromine bond. So this is a CH2, a CH2, and then a CH3. So we've elongated the chain now. I go back to my checklist. Check. That's done. Elongation has now happened. I needed 5 carbons. I've ended up with 5 carbons. Now we need to think about what happens next. I need to get rid of that triple bond. And I need to be able to put just one bromine onto this thing. All right, so we need to incorporate another step. How do we put just one bromine onto an alkyne? Well, I can't add Br2. That's silly. That's going to add 2 bromines, not 1. So I hope that you would tell me that I could take this alkyne and I could add HBr to that alkyne and I would get a product. It's closer. It's not what I need, but it's closer to what I need. Well, let me rewrite the reagent like we always have. CH3, CH2, CH2, carbon, triple bond, carbon, H. And now let me break the triple bond to a double. There we go. 2 sites of attachment open up. One goes here, one goes there. Hydrogen plays with other hydrogens. So it's automatically, by default, going to go right-handed. And then the bromine from the HBr is going to go there. But we're not quite yet where we need to be. Do you know why? Let's look at my product. If I look at this product that I need to end up with, it's all single bonds all the way across, right? So here, I'm much closer, but I need to get rid of that double bond. I need that to a single bond. Do you know how to destroy a double bond to a single? I hope so. I'll take that molecule with the bromine on it at this point. And now this is a CH2 on the end. I just condensed that down a little bit. And if I want to destroy that double bond characteristic, I'll add H2 platinum. And that double bond will now be destroyed to a single bond, which is what this product needs to be. H goes on one side, H goes on to the other. So this is going to be a CH and then a CH3. And there we go, folks. That is the product that we need from this reaction. Now, is this the only way that you could have made it? No, it's not. It's not. Some of you would have went back up here to step number 3, and you might want it to destroy the triple bond down to a double first. And in this step, you could have added H2 Linlar. If you did that, you would have ended up with a double bond with nothing on it, no bromine or anything at that point. It would have just been a chain of carbon with a double bond at the end. 1, 2, 3, 4, 5 with a double bond that happens here. Remember, H2 Linlar is the weakened catalyst. It takes a triple down to a double and it stops. Once you got that double bond, 1, 2, 3, 4, 5 with the double bond, you could have then here added HBr, and you would have ended up with the same product that we would have ended up with going this route. Multiple scenarios for some of these problems, and that would have been perfectly okay as well. Now, let's have a big boy or big girl talk. We're grown-ups. We're in organic. So listen up. I have just taken ethine and I have reacted it with sodium amide to deprotonate the alkyne to make the acetylide ion. I then took the acetylide ion and I elongated the chain by adding propyl bromide to the molecule. When I did that, that made 1-pentyne as a product. I then took 1-pentyne and I reacted it with hydrobromic acid to give me 2-bromopentene. I then took 2-bromopentene and I reacted it with H2 and platinum in a hydrogenation reaction to give me 2-bromopentane. Were you able to follow that? Go back and rewind. Listen to that one more time. Were you able to follow through that explanation using that terminology? Not only that, but I could have also came in here and said the addition of hydrobromic acid followed a Makovnikov addition. Ah. Do you see what I just did? Now imagine that same description happening on the very first day of this class. I probably would have ran you off. You would have went home sweating bullets saying, this guy's talking a foreign language. I have no clue really what he's talking about at all. But if that explanation was somewhat okay with you, congratulations. I am worming myself into your brain. I am slowly taking over and reprogramming you to be a budding organic chemist. Because that's how they think. And if that terminology and that explanation was perfectly okay, then congratulations, you're learning. That's why you're taking this class. That's what you want out of this class, right? Of course it is. All right, now let's try this again. We're getting closer. I need you to get practice. Just like going to the gym and having a workout. Practice makes perfect, and you're going to come back with some big, beefy muscle in organic chemistry. Here's another example. Here's a triple bond. And it wants you to take that triple bond, but look, R group. They're going to let you make that decision on what you want to add, but you have to use a terminal alkyne. That is why they wrote a CH out here. So anything that you want to use after that point, perfectly okay. That's on you. And they want you to react this with an alkyl bromide. And we need to end up with something that looks like this. Oh, gosh. Talk about chain elongation. Absolutely, this is going to be chain elongation. Where do we start? What do we do? Well, once again, I want you to stop this video, write down this example, and try to work it out. Do your map. Kind of plan out what you want to do. Figure out how we can go from the reagent to the left to the product on the right-hand side as easily as possible. But also keep in mind, they're going to let you choose whatever other alkyl group needs to come along with the alkyne. And they're also going to let you choose whatever kind of alkyl group that you want to come along with the bromide. See how far you can get with it. And then in the next video, we'll come back and we'll target this question and we'll draw out the reaction scheme. Good luck.